I'll ask you what you remember about last class.
Yeah.
Okay, guys, you can be prepared to be awed by Gautam's remembering. Especially the two little kids who told me they have short-term memory loss. You can listen to...
I'm the one who has short-term memory loss.
No, you don't. No, you
I
don't.
do.
The person who has that cannot do so well in maths. No, you don't. Okay, come on, do the meditation. Come on.
Dear mindful learners, we begin the session by gathering our attention and focus through a body scan mindfulness practice. Taking a moment to allow your body to settle into a comfortable position. You may close your eyes or keep them slightly open. Willing the spine to lift, the shoulders to soften, and a slight smile on your face. Take a long breath in through your nose and a slow out breath. Bringing your attention to the passage of air through your nostrils, windpipe, lungs, heart, and tummy. Repeat 3 more times. Now bring your awareness to the top of your body, your head, face, neck, shoulders. Sensing the back of the body and the front of the body. Sensing yourself seated. Feeling the contact of your body with the chair or the cushion. Now sensing your upper legs, your lower legs, and the feet. Set your intention to learn with joy and presence. Energize your intention with 3 full breaths. Breathe in, deep and long. Breathe out. You may open your eyes when you are ready.
Gautam, ready? Do you have a notebook, pen and a paper with you?
Yeah.
Do you remember last class we learned about energy, the kinds?
Yeah.
Can you just quickly draw me a rough, just a table?
Oh crap, yeah, I forgot I didn't have a notebook. I need to get one right now. I'll go get that real quick.
Just the 2 types, okay? Mention 5 types and the 2 kinds. Wait, let me just pin. I cannot see it. Kinetics, electrical, mechanical, light, sound. Look, what's the last one? Okay, thermal. Potential is chemical, nuclear, gravitational, and electricity. Let's see if this is right. I'm going to show you the table. You have left 1. There's 5 in each.
Oh, sorry.
Did you put nuclear energy?
Yeah, I put nuclear. Okay, wait, okay. Kinetic, I put electricals, thermal, sound.
You didn't put radiant energy, I think.
I did not.
Radiant energy is energy that you get through radiations.
Okay. And motion energy.
And there's also elastic energy.
Gravity,
but your basic idea
energy,
is right.
Nuclear energy.
Your basic idea is right. Good job, baby. Now let's go to today's lesson. Okay. What do you think happens when you mix two elements? Like in a chemistry lab?
A compound.
Okay, what do you think actually happens?
Like, for example, if 2 hydrogen atoms and 1 oxygen atom combine together, it becomes water.
Yeah, no, I'm not asking you that. I'm asking you, what do you think happens in terms of energy when you mix hydrogen and oxygen? You say it gives water. What do you think happens?
They combine together.
Okay, so is there a transfer of energy? I'm talking in terms of energy.
Oh, hold on. Potential, because it's a chemical formula.
Okay, so is there transfer or is there no transfer between the elements? like hydrogen and oxygen? Do you think there's a transfer of energy?
I don't think so. Oh yeah, I think there is because they're bonding together. They're chemical bonding.
Okay. And do you think when these reactions occur, some elements are given out? Can you name some elements that are given out? Basic elements.
Hydrogen, oxygen,
Okay.
titanium.
Not titanium. Generally, heat and light are basically given out, especially in chemical reactions. Okay. The amount depends on what you're joining or what process you're doing.
Yeah.
Okay.
And carbon, nitrogen, fluorine,
Some more elements.
helium, lithium, beryllium, neon, boron, sodium,
Hey, you have
calcium,
missed a very common element.
hydrogen,
No, hydrogen you said, baby, when we were talking about.
oxygen.
No, oxygen also you said. Hydrogen, oxygen. What's the third element which is very famous?
Lithium.
No, sweetie. Okay, give you a clue. It's present in the air.
Wait, but what's the first letter though?
C.
2 letters?
Plants give. Plants help us.
Carbon.
Carbon
Yes.
dioxide.
Chaitra, right. Chaitra, right. Chaitra, right.
You know more than me, Chetu, because India, they teach you more things.
They
I
teach us more
actually
things.
got carbon dioxide when she said it started with C, but I was on mute.
Okay, you weren't, we heard you. It is carbon actually, not carbon dioxide. Carbon dioxide is combination of carbon and oxygen. We are talking about single elements then. Okay. Yes, Gautam, can you please read this?
Okay.
We are
Energy
talking
is
about chemical energy today. Okay, today is going to be
chemical
all about.
energy is a type of potential energy or energy that is stored due to an object position. For example, a bike that is top on the hill has potential energy due to its position. In the case of chemical energy, the potential energy is due to the positions of the molecules with substance such as food for fuel.
What happened to reading the first paragraph?
Oh, energy is energy that is stored in the chemical bonds of molecules. It exists in the particles that make up food, fuel, and other substances. The food that you eat contains chemical energy, which you can use them to help you, then you can use to help you walk, jump, or move. The chemical energy is stored in batteries and used to power electrical devices. And the chemical energy is wood, gas, and other fuels that can be used to warm our homes.
Okay, so you got right. Why is the energy in food a chemical energy? Why is the energy stored in food chemical energy stored in food? Do you think it is right to call it as potential energy?
Yeah, because kinetic energy means it's moving to do things. For example, mechanical energy is when for example, mechanical energy is a kinetic energy because it's moving. Potential energy is stored energy, it does not move.
Okay. Gautam, once again, I think, guys, are you all finished? Mukund is done, Chaitra is done. What about Shrishti, Sanvi, and Pranav? Are you guys finished? Stopped at science time.
Yeah, let's continue our lesson now.
Okay. So
I already read this.
So these are so remember this, okay? About the chemical energy stored in batteries and food. Okay, this will come in hand in the later part. What's the answer?
All right, the chemical energy that we use to move our body comes from food.
Okay, the second one.
Energy is stored in the chemical natural gas of the substances molecules.
No, those are just the examples of sources of chemical energies.
Oh.
Okay, so you know what are molecules, right?
Yeah.
And what do molecules contain?
Atoms, matter.
Okay, so atoms. So what do atoms contain?
Matter.
No, baby, matter is the whole. Atoms contains protons, electrons, and neutrons. So in between all this, how do you think they stay inside the atom? How do they don't come out everywhere and go out everywhere?
Because they're stored.
Not stored. There's a special bond. That's the answer. There's a special chemical bond in the substance molecule that makes them stay in that place. Okay.
Okay.
And energy
Yeah.
is stored because of the chemical bonding. The energy is stored.
Mhm.
Come on.
All right. Chemical energy is stored in a substance. For example, sugar is made of carbon, oxygen, hydrogen atoms held together by chemical bonds. These atoms don't stick together. Energy is required to keep them in place. The energy is chemical energy. In order for us to use chemical energy to do work, however, it must be released in a chemical reaction.
So what did you understand from this? Can we directly use chemical energy that's stored in all our foods?
Yeah, so yeah, chemical energy stores in unlike all our foods, it prevents it from moving.
No, you didn't answer actually my question. I'm asking food has chemical energy. So do we directly use that energy in the food?
Yeah.
Read the last line again.
In order for us to use chemical energy to do work, however, it must be released in a chemical reaction.
So what is the chemical reaction that occurs in our body when we eat food or drink juice?
It gives us the energy.
How? What chemical reaction occurs? What process helps release energy from food? It's a biology question. What happens when you eat food? No, what happens when you eat
It
food?
digests in your body.
Very good. So that is the process, okay? It must be released. The chemical energy is released during digestion. And that helps us to do work and use the chemical energy from the food. Can you see the diagram on the right?
Yeah.
So the sugar through chemical reaction gives us this. So the chemical energy is converted to kinetic energy. Kinetic energy is responsible for all our movements, as we know. So chemical energy is a form of potential energy. It's again converted to kinetic energy. And during a chemical reaction, the bonds are broken. Okay. When the bonds are broken, then only the potential energy can transform into other forms of energy and new substances are formed. As the example shows, sugar is broken into carbon dioxide and water. And this results in releasing of chemical energy, which is changed to chemical energy,
kinetic,
which allows us to
move.
That's it. Chemical energy is very easy, fascinating thing, not like the other energies. It just gets stored in our body through reaction, gets converted to kinetic energy, and we just use it for all our movements. You can write down these answers. Can you annotate in the system?
Okay, yeah, sure.
Or do you want to write it in a Word doc? I also have a Word doc. Do you want me to?
I'd rather just annotate.
Hey, write in full sentences, please.
Okay, then I'm not going to draw because my hands will hurt.
In case you want, I'll just open the Word doc for you. It's your choice.
Nah.
Use the text option. Hey, chemical energy or chemical? We learned a new word. What word was that?
Chemical substance, chemical bond.
Chemical bonds. Chemical bonds. Yeah, okay.
All right, so wait, is number 3 like a chemical reaction has to work a chemical reaction?
Yes.
Number?
Yeah.
I am learning some of this in school.
You already done this? Okay.
No, I am doing this matter.
Okay. So you're going to rock next time. There's also one more part of energy that
I think our next topic is kinetic and potential energy.
No, next topic is that we are going to do is electrical energy.
I think that's my next topic in school, I think.
Okay. So then you're going to rock, since you know what is kinetic and potential energy, you're well versed with it, how it converts and all that stuff. I cannot see your writing, so it comes only
Yeah,
after you listen.
I'm typing it right now.
Okay.
Is number one chemical substances?
What new substance? What chemical substance?
Can you go back to the
What is
passage?
sugar? No, what is sugar broken down into? That reaction, do you remember on the right hand side in the previous page?
Yeah.
Yeah.
I don't
So
know
what?
what
No, sugar is broken down into two common substances, right? What are they?
chemical substance and
No,
I
no, no,
don't
no.
know.
No, not. What is the name of the chemical substance, Gautam? Don't say I don't know. What's the name? You know the name. I'm like asking what nitrogen, blah, blah, like that.
Carbon.
Carbon and?
Carbon and chemical.
Okay, I'm going to go to the previous slide for 2 seconds, okay, and come back to this slide. Let's see if you're able to see it in 2 seconds. 1, 2.
No, wait, no, wait. Some text was
seconds.
blocking. No, that text was blocking some of it.
No. 1
I
second
didn't
now.
see that.
Okay,
No.
1 second. 1 second. You
No,
know where?
no.
Absolutely not. Hey, you just have to see the reaction on the right side. So 1 second is too much, okay? So
Okay,
I'm
fine.
just giving 1. I
Carbon
gave you like
dioxide.
3 seconds.
Carbon dioxide. Carbon dioxide.
Carbon dioxide, and there was one more. There was one more.
Nothing.
No, just tell your mom or dad we are having fun with science. So carbon dioxide and
Chemical.
hey, Gautam, I gave you 3
Kinetic
seconds.
energy.
What's the other element?
Kinetic energy. Kinetic energy.
No, what's the other element like carbon dioxide which gets released during digestion with sugar? It's a universal substance.
Go back for that one.
Why? I've already gone back and given you 3 seconds.
And can I just have one more last chance?
Okay, I'll give you the formula. Fine. The formula starts with H.
H2O?
Yes. So what's H2O?
Water.
So from sugar during digestion, we get carbon dioxide and water. Okay. Now you can see. Okay. Hey, Gautam, you were pulling my leg. I cannot see a single word even after you wrote the first line on that diagram. Okay. You were simply saying you didn't see the diagram, did you? When I gave you those 3 seconds. And you were like, it's blocking. It is not blocking.
Oh, I thought you meant the text, okay.
No. Always remember, Gautam, whenever there's a diagram, it's going to give you in brief, very fast, what the text is about. So always look at the diagram first to give or get the brief on what is doing. Okay. We are going to learn about reactions, okay? Reactions in which heat is going to be released. So these are known as exothermic reactions. Can you please read this out loud? Slowly, okay? I don't want you to rush like an express train. Read it little slow.
Okay. A chemical
sorry.
A chemical reaction changes chemical energy into other forms of energy. During many chemical reactions, heat is also released in the process. When this happens, it is called an exothermic reaction. In an exothermic reaction, heat is a product of the chemical reaction. An example of an exothermic reaction is when we use gasoline to drive our cars. When you start a car, its engine breaks down the chemicals in gasoline. As the chemical bonds holding the gasoline together are broken, chemical energy changes into mechanical energy that is used to move the car. The release of the chemical energy also generates heat. That's why the hood of a car feels hot after you've been driving.
Understood?
Mm-hmm.
So what is the stepwise process?
Okay, so yeah, so during chemical reactions, heat is in the process and in exothermic reaction.
Okay. So the gasoline, the bonds are broken in gasoline, then it chemical to mechanical energy. Mechanical energy, as you know, is for movement. Okay. And since we are having a chemical reaction there, it generates heat. True or false?
Okay, an exothermic reaction is not a chemical reaction. That's true.
Is it?
No, it's false, I meant.
Is it?
Yeah.
Hey, if I ask, is it, you cannot change the answer. Stick on to your answer. True or false?
Okay, hold on. I'm thinking, okay. So, okay, it's true.
Okay. What about the second one?
Yeah, that's true.
The next one?
True.
The last one?
True.
Okay, the second one. When we immediately start, does the gasoline convert to chemical energy? Does the chemical energy of gasoline convert immediately to mechanical energy when you start a car?
No, it takes time.
It has to undergo chemical reactions, right? So that's a false. Okay, can you see the 3 matchsticks?
Do
you know what is combustion?
No.
Combustion in the simplest term is burning. Okay.
Okay.
So when you're lighting a match, it produces a flame through a chemical reaction called combustion. And for combustion to occur, you need air, not just air, the oxygen in the air should be there. Okay. So chemicals in the match, along with the oxygen in the air, they produce a new substance. So this new substance is not just like that produced. So whenever chemical, this is again an example of exothermic reaction because it produces heat. So there are 3 images that you can see. Okay, one is an unused match, a lit match, and a burnt match. So in these circle where you think the chemicals are stored, in the unused match, where do you think the chemical is stored?
In the red part.
Okay. So in the second one, label the heat and light created by the chemical reaction. Where's the heat? Where's the light? In the second image.
Okay, so the light is on the fire and the heat is on the top of the match.
Can you just draw it and show it for me, baby? I mean, just circle, put H for heat and L for light. Okay. And what's the new substance that's created in the third one?
I don't know. Nothing's potential.
No. Where it is created, draw a circle or a square showing where it is created. I'm not asking you to name the substance. I'm asking, yes, that or the above portion.
I think it's this part.
I cannot see your drawing.
Right here.
Yes, because the bottom portion is not a new substance. It's just the matchstick is burned. You're going to now write and explain why lighting a match is an exothermic reaction.
Okay.
I want it in detail, okay? I don't want you to give me this one-liner stuff. Put that also.
Okay. Hmm.
Where is that sentence? What happens in exothermic reaction?
Hmm.
What happens? Why is it named an exothermic reaction? What happened? Where is this?
Hmm.
Gautam, why is it called an exothermic reaction? Because it gives out.
I don't know.
What does it give out? Exothermic reaction, what comes out?
Light energy.
Light or heat?
Heat.
Thermic. Anything to
Thermal.
do with thermal is heat.
Okay.
Okay. So what do you think happens when you light a firework? Firework.
There's chemical energy stored in it, and then when you light it on fire, it comes out into heat energy.
Okay. And then finally,
And yeah, I think that's it.
finally, what happens? Finally, what happens?
Yeah.
We are going to be seeing that also. We'll have a quick break with the vocabulary activity, then we'll go to that. Okay, that will be the last activity for the day. Okay. Now, can you focus, or do you want me to make you do jumping jacks like I did, or
No.
like I did
No,
the
please.
previous class,
No,
or a
please.
yoga pose? They all did tree pose, all of them. They did the tree pose in yoga. So these are the vocabulary words. Use the vocabulary words and find the secret message. You can do it in any order you want. Okay.
Okay, so
Good job. Why did you remove the E? Good job. Now
So is it
write
like
down the separate.
so is it IOMNBSTCOU?
You have to rearrange, unscramble those letters. I told you the name of a new chemical type of reaction, right? A type of chemical reaction. So that's your clue.
Okay.
Write down the letters that are highlighted, the shaded letters, so that you will have an idea. Write it down above, like find the secret message.
Well,
somewhere.
can you tell me the first letter? That's all I'm asking. Can you?
C.
Okay.
Don't Google it, okay?
I won't.
C is the first letter. The clue is I told you this name when we were talking about lighting a matchstick.
Yeah. I'm trying to remember.
The next letter is O.
Oh, thanks for the clue. Is it?
Why did you remove the C?
Are those the first four letters?
Yes, they are.
Okay, I need to remember how to spell the word.
What's the word?
I know it's combustions, but need to know how to spell the word. Okay.
Combustion. You know how to spell shun. You get it in
Yeah.
so many words. Reaction, combustion.
Oh, I got it now.
Got
That's
it.
the spelling.
Yes, it is. Good job. Wait. How do we clear this? Did you clear? Yeah, good job, baby. So this below the picture, can you see a paragraph? That is the chain of reactions that occur when you set off a fireworks. Can you please read it loudly?
Yeah.
Did you read it?
Wait, no. So a firework, first you place the firework a shell containing a mixture of chemicals in a safe place. Then you light the fuse and the firework heats up, blasting into the sky soon. It explodes in a shower of light. A few moments later, a resounding boom rocks the crowd of delighted onlookers.
So I want you to tell me what are the reactions, conversions that occur here, conversions of energy. For instance, like you say, right, when we switch on a car, it went like from chemical energy to mechanical energy, right? In fireworks, using these, tell me what is the first reaction that occurs? What energy changes to what energy?
Exo something.
No. What? It contains a mixture of chemicals in a safe place. So what energy will be coming first?
Chemical bonds, potential energy.
No, don't say it as potential. You can say it is like sound energy, heat energy, chemical energy.
Okay.
Like that. So what is the first
Thermal.
energy? Chemical
Thermal.
energy. Okay. What?
Thermal.
Thermal, chemical to thermal energy. Then?
Then the thermal energy then converts into heat energy.
Heat energy to?
Then nothing.
Thermal energy is heat energy. They are the same.
Okay.
So what happens?
I don't know.
Soon it explodes into a shower of light. So what energy is that?
Mechanic.
Light energy.
Oh, sorry, light.
Then a resounding boom rocks the crowd of delighted onlookers. What energy is that?
Wait, what was that again? Oh, sound energy?
Yes. So did you get it now? Which is the correct answer? Light energy is also known as radiant energy. Okay.
Okay, so it's chemical energy, thermal, and sound. Okay. And all right, it's the third one.
Very good. So did you get it? How the conversion occurs?
Yeah.
Okay. Now you can sit up straight. We'll do the inhale, exhale and finish the class. Okay. Sit up straight. Close your eyes. Inhale. Exhale. Inhale. Exhale. Inhale. Exhale. I want you to do one thing. Like I gave you an example of this energy conversion, right? This fireworks and the car. Think of one more conversion when you come to the next class. Okay.
I know, but I'm not gonna be able to do that because after this class, I'm going somewhere with my friends, and then
the next
tomorrow,
class is on next Sunday. So you have 1 week time.
No, but I'm going on vacation.
Oh, where are you going?
To Texas.
Oh, enjoy, have fun. After you come back from vacation, think about it. Okay?
Okay. Bye.
Bye-bye.